Is this animegical physics scientifically possible in real life? If yes, how? So today, your Professor Sky of University will calculate exactly how big and flexible this chest has to be to do this complicated jiggling movement, and how fast the chest was moving to dodge the bullet. But we aren't stopping here. We'll also be calculating how big and bouncy this chest has to be to bounce a bomb, and how much force does this jiggle punch produce. In total, we'll test 5 epic jiggle physics moments to prove once and for all if animegical physics is scientifically accurate or not. Experiment 1. The bouncy bomb. So this bouncy bomb is from the anime Batum. Here the villain throws a grenade towards this girl, but instead of exploding, the grenade bounces back. So to analyze if this is possible in real life, we need to calculate the bouncy factor of the chest, and to do this, we first need the exact distance between them. So by looking at this frame, we can see they are 3.5 pillars away, and by analyzing this frame where the girl is standing, and according to fandom Wikipedia, her height is 161 cm. So by measuring and aligning her height with the pillars, we can get the length between the pillars, and the pillar distance comes out to be 2.5 foot times her height. That is 2.5 foot multiplied by 161 cm equals 408.94 cm. And now we add the pillars width. The width of one pillar is roughly 1/4 of her height, that is 40.25 cm. So the total distance between them would be 3.5 times 409 plus 4 times 40, which equals 1591.5 cm or 15.91 meters. That's basically the length of a city bus. So the villain throws the bomb from 15.91 meters, and after the bounce, we can see from this frame that the bomb bounced back half a pillar space plus one pillar. That means 260 cm or 2.6 meters. And as you can see, the outbound angle of the bounce is same as the inbound angle. So now to get the elasticity or bounciness, we'll use this, the coefficient of restitution when inbound angle and outbound angles are same. So COR equals square root of distance out divided by distance in equals square root of 2.6 divided by 15.91 equals 0.40. So the required COR for this bounce comes out to be 0.40. For context, that's less human body and more like a basketball court floor. And class, for humans, the realistic effective bounciness or COR is only 0.05 to 0.15. That already makes this jiggle physics impossible, and even if we increase the size of chest, the elasticity will not change, because elasticity does not depend on the size. So to get this much of bounciness, the chest would need to be made up of rubber. So this jiggle physics is not possible in real life, unless evolution suddenly decides rubber is valid upgrade. So now the score is anime 1, reality 0. Now the second jiggle physics, the jiggle punch from 100 girlfriends who really loved you. So the question is, how much force was actually in this punch, and should this be classified as a weapon? So to calculate this, we'll use a simple formula. Force is equals to mass times acceleration. So by looking at this frame, we can see that the jiggle punch by Hakari throws Karine backwards and even gives her a red face. Now we need to calculate the distance she was thrown, so we'll use Hakari's shoulders width as a reference, which is roughly 36 cm, and Karine was thrown about 2 times that distance, so the total distance becomes 72 cm or 0.72 meters. Now this scene is not fully animated, it is only shown in a single frame, so we'll assume that Karine moved 72 cm in half a second due to the jiggle punch. So now we can calculate the acceleration using this formula. Acceleration is equals to 2 times of distance divided by time square. Putting the values in, which gives us 5.76 meter per second square. Now we can calculate the force, and average weight for her size would be around 50 kg. So force will be mass times acceleration equals 288 Newton, and it is same as getting hit by a good punch. And yes, 288 Newton is totally possible, and a human chest can deliver this amount of force, especially over a short distance. And it can also cause a red face, which matches what we see in the anime. So this jiggle physics is scientifically accurate. So now class, our score is tied, anime 1, reality 1. Now the next jiggle physics question is, can you hide a rocket launcher there? At first glance, this looks totally impossible, but technically you can, but not this big. So first of all, this scenes make it look like she is pulling the rocket launcher from a black hole or a different space, and you are actually right, because in anime or cartoon, this is called hammer space. Hammer space allows characters to pull out anything purely for comedic purposes, but here in our university, we are talking about real science. So the real question becomes, how big does the chest needs to be to hide a rocket launcher launcher. As per my research, you can safely hide only about 10 to 15% of the total chest volume. For example, a Z-side chest has a volume of around 12 to 15k cm3, so that means it could safely hide around 150 to 222 cm3, and you can see some examples in this list. Now for this rocket launcher, the volume of this rocket launcher is roughly 7,000 to 10,000 cm3, so to hide something this big, we would need a chest volume of around 70k to 100k cm3, and that is scientifically not possible yet. So hiding a rocket launcher like this is not possible in real life. So the score becomes Anime 2, Reality 1. Now the next Jiggle physics is from High School of the Dead. So the question here is, does Jiggle physics actually help in reducing recoil while firing a gun? So first, to find this out, I looked up the exact gun used in this scene. The gun is the Springfield M1A Supermat, and these are its specs. Gun mass 5 kg, bullet type 7.62 times 51 mm NATO .308, bullet mass 9.5 grams or 0.0095 kg, muzzle velocity 840 meter per second. So first we calculate the momentum produced by the bullet. The formula is momentum is equals to mass times velocity. So 0.0095 times 840, which gives us 7.98 kg meter per second. Now, if the boy was firing this gun alone, then the total mass would be boy mass plus gun mass equals 63 kg. So the recoil velocity would be momentum divided by mass equals 0.127 meter per second. But in this scene, the boy is firing together with the girl. So now the total mass becomes boy plus girl plus gun equals 113 kg. So now the recoil velocity is 0.071 meter per second. So compared to the firing alone, the recoil velocity is now 56% of original. That means 44% less recoil velocity because the girl is present. So class, congratulations, we have discovered teamwork or jiggle work. And as for that jiggle physics, itself it does not remove recoil, but it does help in spreading the recoil force over time. Let me explain. Normally, when a gun is fired, recoil hits almost instantly in about 0.004 seconds. But by calculating the frames, we can see that after each shot, the chest jiggles for about 6 frames. Since this anime runs at 24 frames per second, 1 frame is equal 0.0417 seconds. So 6 frame gets 0.25 seconds. That means the recoil force is spread over 0.25 seconds instead of 0.004 seconds. That is 62.5 times more time, so the impact is spread out 62.5 times, resulting in less pain. But not all the recoil force goes through the chest. Some of it goes through arms, shoulders and the body. So we assume that for this size only 25% of the recoil goes through the chest. So realistically the jiggle physics reduces the total recoil impact by around 5 to 7%. And because of this setup, the boy only feels around 30% of the left recoil, where the girl absorbs the remaining 70%. So this jiggle physics is scientifically possible in real life, but class, you can get distracted by jiggling and miss shots. But hey, score is now tied again, Anime 2, Reality 2. And now, before we go for the final boss of jiggle physics, if you wanna watch the full version of this video, where I explain 3 more absurd jiggle physics logic, like can you shoot a rocket or can you shoot a laser beam through chest. To watch that, please check out my Patreon and support me, because that will really help me continue making these type of videos and will give me a lot of creative freedom. And more truthfully, because doing these experiments live would be epic. But right now, I'm only working with a potato mobile. But I know, together we'll make these wild science adventures even bigger. Now back to the video. Now class, before we end this lecture, we come to the most iconic jiggle physics moment, and that is also from the High School of the Dead. The question is simple: is dodging a bullet with jiggle physics possible in real life? So first, by analyzing the anime frame, you can see the initial and the maximum jiggle position. In the maximum position, the chest almost jiggles for its entire height. So according to FanWiki, her height is 174 cm and her chest size is 83 cm, but we only need the main chest size, not the full body measurement. Chest size is measured as a circumference, so to calculate the width, we'll use this formula. Diameter equals to circumference divided by pi, so 83 divided by 3.14 equals 26.4 cm. Now the average height of the chest is around 40 to 50% of its width, so taking 45%, that is 11.7 cm. Now from the maximum jiggle frame, we can assume the chest moved around 10 cm. So now we can calculate the strain. Strain equals to stretch divided by original length, so 10 divided by 12 times 100, which gives 83.3% strain. But in real life, a chest can only move about 5 to 10% of its height without hurting itself from 50 15 to 20%, it would already be an injury, and at 80%, it would just detach itself. So this exact movement is not possible. But technically, if the chest size was 100 cm, then a 10 cm jiggle could be possible. Now let's calculate how fast it was moving to actually dodge the bullet. As we calculated earlier, the gun has a muzzle velocity of 840 meters per second, and the distance between the shooter and her is approximately 10 meters. So the time the bullet takes to reach her is time is equals to distance divided velocity. That will be 11.9 milliseconds. So to open even a 1 centimeter gap in that time, the required chest speed would be velocity is equals to distance divided by time, that is 0.84 meters per second. But since the motion must accelerate and decelerate, the peak speed must be higher than the average, so a reasonable estimate would be around 1.5 to 2 meters per second, which is about 5 to 7 kilometers per hour. And that level of speed is clearly not possible for a chest in real life, unless the chest is powered by a V12 engine. So sadly, dodging a bullet using jiggle physics is not scientifically accurate. With the final score of Anime 3, Reality 2, most anime jiggle physics are not scientifically accurate. Thank you to my patrons for funding this research. I love you all. Kiss kiss. Mwah.